Good morning, students. I hope everybody is fine. So, you already have gone through the various type of presentations that we have sent to you, and hence today we will study about, as you can see on the board, the topic is motion, and we want to study about the graphical representation of the various types of motion. So, before you put up in this topic, I will prefer that you should or must have gone through those presentations which is being given to you in the various PPT format and video format. So, before we study this motion, there is one word I hope you should be knowing it called mechanics. So, what is mechanics with respect to physics? So, it is the branch of physics, write it down, which deals with the branch of physics which deals with the condition of rest or motion of materials. Okay, condition of rest or motion of material objects around us. So, that is mechanics. So, in mechanics we are going to study a topic called kinematics. So, this is the one we are going to study today. So, again write down it what is kinematics. So, it is a branch of mechanics now. It is a branch of mechanics which deals with the study of so kinematics is the branch of mechanics which deals with the study of motion of object. Write it down, motion of objects, motion of objects without, underline the word, without considering the cause of motion, without considering the cause of motion. So, you know these mechanics have lot many branches. Today we are only dealing with kinematics. The opposite of kinematics for the students, those who want to know, is called dynamics. The definition is same, but only difference is that the motion of the object taking into consideration the cause of the motion. Okay. So, we study the motion of the object considering the cause. So, what is cause and what is not, we will deal with this topic as we come into higher classes. For the time being, you should know there is something called mechanics, and under the mechanics we are studying the topic called kinematics. So, these things should be known to you before we begin the topic. Now, moving into the next one. So, before you move into this topic, I hope you should know the various terms under this topic. So, first term that you should know, of course, is rest and other is motion. So, what is rest? So, you should know that it is body said to be rest if it does not change its position with respect to surroundings, and if it changes the position with respect to surrounding, we call it is motion. So, as a result, rest and motion both are relative terms. So, what do you mean by that both are relative terms? It means that, for example, you can see a passenger if sitting in a moving train is at rest with respect to the fellow passengers, but they are in motion with respect to the object outside the train. So, that means the same time they are at rest also and in motion also. That means these two terms, rest and motion, are relative terms, and that should be known to you. And then we move into this topic of motion. So, by this time you should be knowing about the various terms in this particular topic. The first is the speed, and you should know what is speed, then its various types such as uniform speed, variable speed, average speed, instantaneous speed. So, we already have sent these videos for that reference. So, please go through them properly, and then you should also know that what is motion. So, we have two type of motion, uniform motion and non-uniform motion. That should be very clear in your mind. Similarly, you should be knowing about what is velocity. So, in that term, it again has lot many parts that has to be read about or learn about, such as the uniform velocity, variable velocity, average velocity, instantaneous velocity. So, these terms must be very clear in your mind before we view this particular topic which I am going to present. And similarly, after velocity, the term that should be known to you is acceleration. And again, acceleration, we have lot many subtypes. We have uniform acceleration, non-uniform acceleration, average acceleration, then instantaneous acceleration. Then we in this type we do have two new terms. One is called the positive acceleration. We will use this term lot many times. So, positive acceleration and negative acceleration. So, when I say positive acceleration, it means the velocity of an object increases with time. That is, velocity increases with time, that is positive, and if the velocity of an object decrease with time is called negative acceleration. It is also referred as retardation or deceleration. So, they are same term, whether I use negative acceleration, retardation or deceleration. So, these all term will be at par, you can say it. So, these things should be known to you. As a result, the topic which you are going to study becomes easier for us. And then we should know, as the topic says, that we are going to study the graph of these types of motion. Then what is a graph? So, it is a geometrical relationship. So, it is a geometrical relationship, okay? Geometrical relationship between two quantities, geometrical relationship between two quantities on x axis and y axis, okay. So, these terms should be known to you. So, we plot the graph of the two quantities plotted on x and y plane. So, after knowing all these terms, we should know that what it means. So, one axis, two axis, give it a cap on the sides. This is referred as the point of origin, and normally we place, and generally we always put time on x axis, okay, and other variables, whether it is speed or that is called the distance or displacement or velocity, acceleration, on y axis, okay. So, make sure time is on x axis and other variable on the y axis, and we plot the graph. And as we plot the graph, we should be knowing that this part, normally we say rise, and on x part we use the word run, okay. So, these two terms will be used for graph explanation, rise and run. Then we already have told about these things in the classes when you plot the graph. So, this side we have a positive axis, this is also positive, this goes into negative aspect, and this also goes to the negative aspect of the quantity to be drawn. So, these are some fundas that should be known to you, and then write down some information. So, straight line graph, that is straight line graph, whenever we draw the straight line graph with this straight line graph like that. So, it has a single slope, and when we draw something like this called the curved graph. So, it has multiple slopes, okay, multiple slopes. So, if you know all these things, so the rest of the topic will become easy for us to understand it and to let you know about it. So, let us begin the topic and see how much we have with us in the informative form and how much we know it. So, please view these graphs carefully and try to study what we have been told to you or letting you know it. So, first is the distance time graph. Okay. So, distance time graph. So, in distance time graph, in first case, that is this graph which has been shown to you, you can see the body is at rest. Now, why the body is at rest? Because the slope is 0, this straight line slope is 0. So, speed of the body is 0, and if the speed of body is 0, that means the slope is straight line, or you can say a horizontal line on time axis. So, that is the first case when the body is at rest. In second case, you can see the body is moving with a uniform speed. So, you can see a body is moving with a uniform speed. Now, how you know the body is moving with uniform speed? So, you can see the distance time graph is straight line inclined to time axis. It makes some angle or inclined at time axis. And as the body of the graph passes through O, that is the point of origin. So, distance travel at time 0 is also 0. So, at time 0, this say if it is 0, distance travel is 0. So, as time increases, distance increases. So, it is with a uniform speed the body is moving straight line. Then if you move further, you can see in third case, here the body has a accelerated motion. Why? Because you can see it give you a slope of a graph increasing with time. The slope of the graph goes up, and because slope of the graph is increasing with time, so this represents speeding motion or accelerated motion. And for the last one, you can see here that this particular object is showing a deaccelerated motion, that is speeding down. Why? Because slope of the graph, the slope of the graph decreases with time. So, this is a slope, as it reaches the apex, it keep on decreasing. So, as a result, we give it a represent decelerated motion because slope of the graph is decreasing with time. So, that should be known to you. And just to add on to it for your information, say if I put a number 5 here, we can also see some graph like that, straight line, this is straight line. Say this is the distance, this is the time, as I have told you, distance, and this is the position, or we can call it distance on the y axis. Sometimes you can also find a graph which is shown like this. This is A, this is B. Now, what you can predict about that? So, you can see this time graph is again a straight line which is parallel to y axis or distance axis. So, it represents infinite speed. It represents infinite speed. So, infinite speed which is just not possible. So, you have to have some speed, you can't have say we have infinite speed. So, hence in reality you can call it this graph is not possible. Okay, you have to write it is not possible and then give the reason because it represents body with infinite speed. Okay. So, these are some of the graphs that we have just seen or read about the distance time graph. So, you should know. So, we have various types of distance time graph when the body is in motion or body is at rest or body with uniform speed. So, these time you should be knowing about it. Now, let us see the other type of graph that you should be knowing it, called the velocity time graph. So, make sure the topic is velocity time graph. So, again in this case, when the body is moving with uniform velocity, this is a uniform velocity, then you can see if it is moving with uniform velocity, the Vt graph is a straight line parallel to time axis. So, it is parallel to time axis. So, as a result, the slope indicates 0 acceleration. So, as it is parallel to time axis, and this represents the uniform velocity. So, when velocity is uniform, as this case, so we have no acceleration. Then when the body start from rest, second case is when the body is starting its motion from rest and with a uniform acceleration. So, in this say you can see the greater the slope of Vt graph, greater will be the acceleration. So, greater the slope, greater. Here you can make sure the body start from rest and move with uniform acceleration. And if you further move into the topic, what happens? That when a body moves in moving with uniform acceleration and its initial velocity is not 0, the body has moved into a positive slope, but you see it won't start from rest or from 0. So, it has some velocity that you should know, the term is called u or initial velocity. So, the body is moving with certain initial velocity with it, and in that case you can see the graph projection is somewhat different. So, these are some type of velocity time graph. So, you can see here again the further type of velocity time graph that you can say that when the body is moving with increasing acceleration. Now, see there are lot many types of graph coming to you. So, make sure about them, write them very properly, draw them in copy properly, so you can relearn it as the PPT or presentation gives over. Now, here again you can see the body is moving with increasing acceleration. So, you can see the slope increases with time, slope is increasing with time. So, as a result, in this case the body is moving with a increasing acceleration. Now, the second case you can see that when the body is moving with decreasing acceleration. So, when the body is moving with decreasing acceleration, you can see smaller change in velocity are taking place in the equal interval of time. So, the Vt graph bend downwards. This graph is moving up and then downwards. So, like that, if it keeps on moving like that, so we say the bending downwards represent a deceleration or decreasing acceleration. So, these two terms, increasing acceleration and decreasing acceleration. And the next one, the body is moving with a uniform retardation and its initial velocity is not 0. Okay. So, body is moving with a uniform retardation, that is uniform retardation, and the initial velocity that is start from here is not 0. Here initial velocity was 0, here it is not 0, but it is moving with a negative slope, you can call it. So, as the theta is more than 90, so this is the theta is the angle which is more than 90, it has a negative slope. So, we call it a negative slope. Okay. And the Vt graph represents uniform negative acceleration. Okay. Uniform retardation or deceleration or uniform negative acceleration. So, these terms should be very clear in your mind before you come into the graph topic and read about them, and make sure that these graphs should be drawn properly in your copies to know more about them in detail. Now, here is some catch up point. Since in this chapter we are dealing with basically a rectilinear motion. So, we will deal with the object moving at a constant acceleration. Okay. So, as the acceleration is constant, so we have the cases here. You can see acceleration on y axis, time on x axis. So, again in both this graph you have a horizontal line like this. So, it is a description of graph below. It shows that the object which is either stationary or traveling at a constant velocity, the acceleration is 0 over time. And in second case, you can see in second case we have just seen that the object moving at a constant acceleration, and in this case acceleration is positive, and I have told you that it can only be negative, that we will study over the time period. But for the time being, you should know, since in this class we are basically dealing with the acceleration time graph with rectilinear motion. So, these two graphs should be or must be known to you. Now, after these graphs, generally we have the topic which is referred as, and you should be knowing it, and that these two graphs should be known to you. Sometime you will also find a graph like this, and here is the speed format, there is time axis, it is origin. You will find something like that. Okay. So, again this is a speed time graph, and the condition wrote it down that when the body is projected upward, okay, body is projected upward. So, the body is projected upward. So, when the body moves, its speed decreases uniformly. Make sure the body is thrown up, the speed decreases. You can see the speed goes down uniformly and becomes 0 at some point of time. And as the body moves down, the speed, as the body reaches the height and thereafter the gravity pulls down, so its speed increases uniformly. So, it returns with the same speed with which it was thrown up. So, it returned with the same speed, you can see, as it has thrown up. So, this graph you will find in your respective textbook. So, this is the graph illustrating the speed time graph with projecting body upward. So, if the object is projecting upward, then we have this type of graph. And what happens if you have a graph like this? So, again draw it the same x axis and y axis, give it a cap as I have told you in the earlier. And if the graph is somewhat like this, then what you can call it? So, in this case it represents that as the ball dropped on the ground from a certain height, okay, the object, or say here in this case the ball is dropped, the ball is dropped on the ground, okay, on the ground, the ball is dropped on the ground from a certain height, okay. As you can see that, so as the ball falls, its speed increases. So, as the ball, say it's drop on the ground, the speed, it has a graph, it increases, and as the ball bounce back after hitting the ground, the ball say bounce back, the speed decreases uniformly, speed decreases uniformly and becomes 0 at the highest point. So, these two graphs, one is the ball projected upward, other is the ball dropped on the ground from a certain height. These two graphs we do also take up in the class for further clarification and understanding, but for the time being you just write them down properly and try to understand these types of motion that we have done it over a period of time, and make sure that as the topic is discussed with you, so these things should be well understood in the respective words, and thereafter make sure that whole thing that we are going to study or we have studied in the topic should have been properly understood in the graph, and try to draw this graph carefully, study them properly, and revise them as much as you can. Thanks. Have a nice time. Bye.